This is an application problem when looking at linear approximations and differentials. So we talked about Proto's Pizza, where they are claiming that their pizzas, their large pizzas, have a diameter of 50 centimeters, so that would mean a radius of 25 centimeters. But they're not perfect because if they have humans making these, they're not always going to be exactly 25 centimeters. But the claim is their maximum error is 0.5 centimeters. So maybe they'll have a radius of 25.5 centimeters, or maybe they'll have a radius of 24.5 centimeters. But it'll never be a bigger error than that. So we want to figure out the maximum quantity of pizza we could lose if they make this maximum error. And to approximate this, we're going to use the idea of differentials / linear approximation. So we know that the claimed area size is going to be pi. Area is going to be pi times 25, the radius, squared, which is 625 pi. Okay, that's how big they're claiming their pizzas are, but it could be larger than that or smaller than that depending on their error. So how we're going to do this is we want to think about the dy, the possible change in the output that could happen if we have a possible change in input of 0.5 centimeters. So what we do, remember that I guess this would be different variables here, right? If, dA, dr, right? But we'll just keep it at dy dx. So if we say dy, we should do the right notation. Okay, so dA, dr, right? Change in area with respect to the radius is 2 pi r, right? So this is our derivative of the area formula with respect to r. Okay, so we're trying to figure out this possible change in area when we already know dr. Remember, dr is 0.5. So we say dA. Here, let me actually plug some stuff in. Okay, so dA over 0.5. That's equal to 2 pi times the claimed radius 25. Okay, so what's that possible dA? Well, that's going to be 2 times 25 is 50, so it's 50 pi times 0.5. Okay, so then dA equals 25 pi. We want to make sure we're using correct units, so that's centimeters squared. So 25 times pi, about 75 centimeters squared. So you could either expect to have 75 square centimeters more of pizza than normal, or you could have 75 square centimeters less. So it depends on if you're lucky or not. But we use this idea of the derivative and the slope at r equals 25 to approximate how much a tiny little change in the radius would affect the output. So just remember always to differentiate. Remember what information you have. In this case, we had dr, and we knew the current radius, and then we used that to approximate dA, which ended up being 25 square centimeters.